Lorena gets a train at the same time each morning to go to work. She gets a train at the same time each evening to come home. The probability tree diagram shows the probabilities of each train arriving late. Complete the probability tree diagram. This is a whole new question, so I'm going to leave this alone. Let's get these 2 marks first. Key parts of this, same and same. Probability tree diagram, it's a probability question. We need to bring back to mind all of the things that are relevant to probability. So we've given some probabilities. Just drawing these in big so you can see them. Sometimes she's late to work. It doesn't actually say that here, but sometimes she is late for her train. Sometimes she's not late. So in the mornings, she's late 0.13 of the time, 13% of the time. We don't need to know in percentage, we need to stick to decimals. The probability that she was not late is 1 subtract that number. Or 0.87. These two have to add up to 1. Same here. And 0.94 here again. This here, this dotted line means that what we have to do is actually, this is looking at the probability that she was not late and not late. So the probability that she was actually on time for both trains is this number here multiplied by 0.94. Sneaky to put this here. I noticed that this didn't have a dotted line here. So it was just like, oh, that's a bit odd. I'm going to write the number anyway. But then I spotted that this was here. When you're looking here, you have to add them together to get here. But when you're looking at the probability of 2 events, we multiply them. 0.94, and then, which is this answer here. And then we're going to multiply it by 0.87, which gives me 0.8178. I'm just going to write the whole number there. There's no need to round it.
Hello. How are you doing?
Right. For a day that Lorena goes to work, work out the probability that the train to work and the train home will both arrive late. Okay, the probability. I thought this was about when she is late, but actually this is when the train is late and not late. Okay, work out the probability of the train to work and the train home will both arrive late. So this is the train will arrive late, and this is the train that arrives late. So we do 0.13 multiplied by 0.06, just like we did here, but we're looking at a different branch. Which gives me, oh, this is in standard form. That's not helpful, but you can put it there. You could put it in standard form. Still correct, but actually what I'm going to do is convert that. I'm going to move 3 steps, 1, 2, 3 to here, which puts my 780, 0.0078. This is neater. I believe this will give you those full marks. Certainly writing this will give you 1 mark, this here. The problem is if you convert it and you get that wrong, you miss the mark. So what I'm going to do is I'm going to check that I have done my standard form conversion correct. Because if I now put in 0.00780, it actually gives me the same number as I got before, at 7.8 multiplied by 10 to the negative 3, which is this here. So I know that this is right because I've put this into my calculator and got the same answer as I got here. A little bit complicated. Your calculator may not put this here. There is a setting that allows you to change it, but I've left it on there because it's really useful for standard form questions on a calculator paper.